All right, go ahead and get, I think paper notes would be best for this. All right, so we're going to try to make a decent video since we've got like, daggone what, a third of the class out today. So we're dealing with batteries and how you can like connect multiple batteries into a bank for different purposes. So I'm going to start off with a scenario that maybe some of you have some experience with. How many of you have ever been to like a tailgate party, or you've like done activities centered around a vehicle? Okay, cool. So let's pretend we're going to picture this scenario. Somebody goes tailgating and they're running their lights and they're running their speakers and they're running, I don't know, maybe they got an inverter on the car battery and they're running something else. I don't know. Some people's kids. So anyway, and what happens is they end up, the party's over, the game's over, they go back to their vehicle and they go to start it and the battery's drained too much. You think that's a possibility? So the party's a little too hard with their vehicle and the battery has discharged so much that the car won't start. So they either need to jump or some other way of getting home. So for the next time, they decide, you know what, I like this tailgating lifestyle. I want to upgrade my vehicle's battery system. And maybe they even wrecked the battery. Who knows? Can you discharge a standard car lead acid battery so much that you actually wreck it? Yeah, they're not designed to be fully discharged. So they decide they're going to upgrade. They get a new battery tray, and they're going to have they're going to buy 2 new batteries for their vehicle to increase their storage. I'm going to draw a picture here. You guys can draw along with me if you'd like. 12-volt battery, so I've got my little 12-volt, negative on one side, positive on the other, right? The terminals. And battery connection types. And let's say it's a 100 amp hour battery, which means it can supply 100 amps of current for 1 hour. Does that make sense? It's a lot. Or you could do 1 amp of current for 100 hours. Does that make sense? At 12 volts. Now, again, the whole reason they're in this situation, though, is because they fully discharge. You can't fully discharge. So they say, you know what? I'm going to add that second battery, 12 volts, same exact, they've got to be the same type battery, guys. Another 100 amp hour battery. And they want everything to work properly in the vehicle. Everything in the vehicle is designed to work on a 12 volt system. Does that make sense? So they have to wire it properly. They want to increase storage, not voltage. So what they're going to do to get the double, in this case, they're going to add those capacities together. They're going to end up with a 200 amp hour battery pack or battery bank. But the 12 volt system remains a 12 volt system because of how they wire the batteries together. They're going to go in a parallel configuration. So negative to negative, positive to positive. It's called a parallel connection. Okay. In a parallel setup, you add the amp hours or the storage, right? The capacity, but voltage remains. Does that make sense? So just by having 2 batteries instead of 1, they double their capacity, the storage capacity, their run time on the things that they're powering, but the voltage stays the same. Now, I asked this question to both my 3rd and 4th period, and I got very different answers. How many of you ever dreamt or have ever dreamed, or would it still be dreamt? Sure. Of living in a little off-grid cabin in the woods. At least part-time, like maybe once a week, you just to get away, you go out there. Okay, so several. All right, it's more like my third period. Fourth period, almost nobody. They're like, oh, I like all my electronics. Anyway, for that setup, you might prefer, because of the way things are with the wiring size and the appliances that you're going to run, you might choose to run a 24-volt system. We can actually use the same description of the batteries. You wouldn't want to use a lead acid. You'd want, because you're going to want to actually discharge this because you're running power and you don't have an engine to start to recharge it. Does that make sense? So you're probably going to run lithium ion phosphate LiFePO batteries, lithium ion batteries. But we can still look at it as a 12-volt battery, and you have another 12-volt battery, and we'll say that they're 100 amp hours. You're actually going to get more use out of that, though, because you can drain them down more without hurting them. And again, you want a 24-volt system. So we're going to run them in series instead of parallel. In that case, you add the voltages, but storage or capacity, I'll use the word capacity, remains the same. Current capacity. So we end up, here we add the amp hours. In series, you add the voltages. So you end up with a 24-volt system. These stay 100 amp hours. You're not adding those together. So what the wiring looks like here is you're going to go positive to negative, or negative to positive, whichever you prefer. And then your appliances will run on this. Okay? All right, now I got a question for you. Check on understanding here. Remember, watts equals amps times volts. Which of these can supply more power total? The series setup or the parallel setup? Parallel? I hear one for parallel. Which one can supply more power? They're the same. They're the same. So 24 volts times 100 amp hours, right? Amps. What's this over here? 200 amps times 12 volts. Wouldn't you come to the same number of watts or watt hours if we left the hours there, which we should? In both cases, you'd end up with what? How many watt hours? Huh? 2,400 watt hours. For both. So they have the same overall capacity. Questions on that? Now there's another way you could set up, might take another couple of batteries, but so we've got our parallel set up, or connection type, we've got a series connection type. We could also run parallel. So you could have a series and parallel. So let me go, can I erase this? Okay, so I'm going to erase this. We could actually have another 12-volt pair, 100 amp each, amp hours. Okay, we're going to run them in series. So this is going to be 24 volts, right? This is going to be 24 volts. This is 100 amp hours. This is 100 amp hours. But what if we went, hey, let's go from positive to positive and negative to negative. Now we had them in series. This one was in series, this one was in series, but we just connected them in parallel. So now what you have, because we went in parallel now, you stay 24 volts. The total thing, the whole shebang is 24 volts. But what's the capacity going to be? This was 100, this was 100. You're going parallel. You're going to add them, right? So you're going to have 200 amp hours because you did both. That make sense? Okay. Let's go to our paper that I haven't given you yet. Yes. So, no. Hold on. Let me explain. Is there two there? I think. It's a great question. Let me explain. Did I miss anybody with a paper? All right. So to answer that question real quick. So she said, why wouldn't it be 400 amp hours? So this by itself, this bank, before we hooked it in parallel, was in series, which means you add the voltage, but the capacity stays the same. Were you following up to then? Yeah. So and we said, hey, what if we had two of those and we hooked them together in parallel? Well, with parallel, you add the amp hours, but the voltage stays the same. So if you had 24 volts here, 24 volts here, you put them in parallel together, it stays 24 volts, but you add the amp hours. Here you had 100 because it stayed the same because it was in series. So you have the 100 here, 100 here, you add those together. You're treating them as a bank here and another bank. You're nodding. Light bulb went on. Okay, all right. What's up, Gordon? Cutting through my room. That's terrible. All right, so everybody got a paper? We're going to go through this. I'll do the reading together, and then we're going to take our time going through the questions. Give everybody a chance to think on every question before we did public answer. Batteries can be connected in three common ways. Series, like this. Parallel, like that. Or a combination, like this whole shebang here. In a series connection, the positive terminal in one battery connects to the negative terminal in the other. So as we had here, positive to negative. Voltages add in series while the current capacity remains the same. For example, two 1.5 volt batteries like AA's in series produce a total of 3 volts because 1.5 plus 1.5 is 3. Everybody follow? In a parallel connection like the one over here, all positive terminals connect to each other, all negative terminals connect to each other. Voltages remain the same, but the capacities are added together. And it says because the cells share the load. For example, two AA batteries at 1.5 volts in parallel still provide 1.5 volts, but they have twice the what? One and a half volt and another 1.5 volt in parallel. The voltages stay the same, so it's still 1.5 volt. But what happens to the capacity? It doubles the capacity. There's more storage. There's more energy stored. Okay. And then finally it says you could have a mixed or series parallel arrangement like this. It combines the methods. Groups of batteries in series, so we have a pair of batteries in series here and another here, are placed in parallel with identical series groups. This changes both voltage and capacity depending on how you set it up. When analyzing any circuit with batteries, we use Ohm's law. So voltage equals current times resistance. All right, to the questions. And I didn't add any words to the word bank, so this should be pretty straightforward. In a series connection, the what of each battery add together. So series, you add the voltage. Number two, in a parallel connection, the what of the batteries increases. The capacity increases in parallel. Good. The formula that relates voltage, current, and resistance is, of course, Ohm's law. Yep. Two 12-volt batteries in series provides how many? Hold on. Yeah, I was on a different question. Yeah, you add the voltages in series. So yes, you'd have 24 volts total. Number 5, in a mixed configuration, you combine series and parallel connections like we did in the big one. All right, multiple choice. Two 3-volt batteries are connected in parallel. What's the total voltage in the circuit? It stays 3 because it's in parallel. The voltage stays the same. Number 2, 4 identical 1.5 volt cells are connected in series. What's the voltage? It'd be 6 because it says there's 4 1.5 volt cells. So 4 times 1.5 is 6 volts. Number 3, which statement about parallel battery connections is true? Do voltages add and capacity stay the same? No, that's in series. Do voltages stay the same and capacity increases? Yes. So 3 is B. Just slow me down if you need me to. A circuit has a total voltage of 12 volts and a resistance of 6 ohms. What is the current? 2 amps, because volts divided by ohms gives amps. Good. Number 5, and this one, just like number 4, AI didn't finish writing the sentence. You make 2 groups of 2 groups of 2 1.5 volt batteries in series. Each series pair is 3 volts. And you link them together in parallel. What is the voltage of the whole system? It'd be 3. So you have 1.5 volt batteries in series together here, 2 of them. 2 more 1.5 volt batteries in series here. So each would be 3 volts. But then you run them in parallel so that stays 3 volts. So the answer there is actually B or D, because for whatever reason, they're both 3 volts. Questions on that one? And then number 1 in the open-ended questions, it didn't say anything about this in the reading, but we can still answer it. It says, explain why it's unsafe to mix batteries of different voltages or charge states when wiring them in series or in parallel. You shouldn't do it. Why? Oh, everybody jumps to it can explode. So the one that's in better shape is going to degrade because of the draw from the bad battery. Okay. Another thing you don't want to do is mix battery types. So if you've got a lead acid battery, you can't mix that into a bank with lithium ion. You never want to mix chemistries. It probably won't explode, but so batteries will often swell though. They can actually, they can go through thermal expansion and swell. Have you ever seen a battery where the casing's actually swelled out? So do they explode? They might expand to the point where they split, and then you can have leakage, right? Can you potentially, like especially with lithium-ion batteries, can you have a fire? Yeah. Yep. All right, number 2. A device needs 9 volts to run. Your kit, whatever your supplies, I guess, has only AA batteries, which are 1.5 volts. Describe 2 ways to obtain 9 volts. Go.
You add more batteries in series.
You put them in series. How many would it take to go from 1.5 to 9 volts? You'd need 6. Yep, you need 6 of them in series. Huh? No, not 7, just 6. Because then you'd have 10.5 volts. We want 9 volts. Okay. And it asked for 2 ways. I guess you could do another set just like that and then connect them in parallel. So you'd still have a 9-volt system, but then you'd have double the capacity. That'd be pretty sweet. All right, and then the last question on here, number 3, a battery pack is made of 3 4-volt batteries in series. So how many volts? 12. 3 times 4. 4 volts, 3 batteries. So 12 volts is connected to a resistor that draws, and it draws 2 amps. What is the resistance in the arrangement? So ohms resistance is equal to volts divided by amps. We had 12 volts and we had 2 amps.
6.
You had it. Absolutely. 6 ohms. You guys made easy work of this. Everybody feel pretty good on this?
Yes, sir.
Okay. All right. Cool. Shh. So I have something for you. As promised, I think I told most of my classes that I would make this. So for the assessment next week, I made a notebook LM for you. I put in all the videos that I've made. I pulled one of the CK12 lessons that I didn't have like a standalone video for, and I pulled the text actually off the paper I just gave you. And I rolled it into one notebook LM. There is a mind map. There are flashcards. There's a quiz, guys. I'd probably, I don't know, I might do the quiz first if I were you and see how you do. If you do really, really well, you might not need to study as much at least. If you don't do so well, shh, guys, I'm talking at you. Oh, you might want to look at these, right? So I got a 7-minute AI derived from me and from our sources video. It's okay. The artwork's not always accurate, but the content is. Yeah, flashcards, quiz, mind map. It's all there for you. Questions, comments, concerns? Figure midweek next week for the quiz or for the test, whatever it is, the assessment, the thing, and the stuff. Yep.